You're saying you're from some weird alternate Earth?
How many Earths are there?
Some people think every possible Earth exists.
The idea of parallel universes has fascinated fiction writers and fans throughout the years. There are numerous books, movies, video games, and TV series based on this notion, which makes us wonder, is our universe just one of many parallel worlds, or is this notion beyond the pale of science? It's not often that someone is able to communicate the complex theories of parallel worlds, or a multiverse for that matter, in a way that's entertaining, informative, and easy to understand. Luckily, Brian Greene is just that kind of person. He postulates that, however strange the idea of many universes may sound, it fits in very well with the history of science.
There has been work in the last few decades, and some very active research even in the last few years, which has suggested from the mathematical analysis that what we have long thought to be everything may in fact be a small part of something much, much bigger. And that much bigger expanse may include realms that should rightly be called universes of their own, and thereby giving us this notion of multiple universes, the multiverse. Now, there's a way in which, however strange that idea may sound, it actually fits very well into the history of science, right? We have gone through, over the last 500 years, what might be called a series of cosmic demotions. Right? We once thought that we were the center of everything. The Earth was the center. And of course, there were very brave and courageous individuals who were willing, literally, to risk life and limb to note that their mathematical investigations suggested that the Earth is not the center, that the sun is the center. And then, of course, even when that idea finally was accepted, we learned that the sun is really not that special. There are many other stars. There are at least 100 billion stars in our galaxy. And then we learned that our galaxy is not that special. There are hundreds of billions of other galaxies out there, each with hundreds of billions of stars. So if you follow that progression, the notion that our universe may not be special, that there may be other universes out there, perhaps is not all that surprising.
Many physicists have long claimed that all of the observable universe is one self-contained event. But there is a growing number of scientists who claim there is a real chance of parallel universes existing, based on the current state of physics. Brian Greene has devised classification schemes for the various theoretical types of multiverses and universes that they might comprise. Greene's classification is based on the use of mathematics to describe quantum states, or quantum branches, which are believed to exist in the multiverse. Brian Greene uses many references to string theory and quantum mechanics to explain why parallel universes could exist. According to him, it could be possible for a parallel universe to be created by a disturbance in space-time. There are a few different ideas of how parallel universes might come into being. One is the so-called eternal inflation. According to this model, the inflationary phase of the universe's expansion lasts forever throughout most of the universe, because the regions expand exponentially rapidly. Most of the volume of the universe at any given time is inflating. Eternal inflation, therefore, produces a hypothetical multiverse, in which space is broken up into bubbles or patches, whose properties differ from all physical possibilities.
Matter can only arrange itself in finitely many distinct configurations. And what does that mean? Well, I like to use an analogy with a deck of cards. If you have a deck of cards, you begin to shuffle the deck, the cards will come out different orders. You shuffle it again, the cards come out a different order still. But you know that there are only finitely many different possible orders of the cards in a deck, which means if you shuffle that deck of cards enough times, infinitely many times, you know that the order of the cards sooner or later has to repeat. No way around it. Similarly, if space goes on infinitely far, the configuration of particles, region by region by region, must repeat too. There simply aren't enough distinct possible configurations to go around. Now, what does that mean? Well, I am just a configuration of particles, as are all of you, as is the Earth, as is the sun. If the configuration of particles that we show in evidence here repeats somewhere else in the cosmos, as it must by that little argument that I just gave you, then that means that out there in the cosmos, there are copies of you and me, the Earth, the sun, and everything else. Reality as we know it has parallel versions, parallel realities, parallel universes out there in an infinite cosmos. And in fact, if you think about it, it's even easier for the particles in some region to almost replicate the configuration that we see here. So in some of those other universes, some decision that you may have made, which amounts to particles in your brain and vocal cords having moved one way or another, they would have moved in a different configuration. You would have made a different decision. All possible realities would be out there as long as they are compatible with the laws of physics.
This would indeed explain the mystery of why the constants of nature appear to be fine-tuned for the emergence of life in this universe. Most of the multiverse would be unsuitable for life to evolve. With other words, intelligent observers exist only in those rare bubbles in which, by pure chance, the constants happen to be just right for life to evolve. Another famous idea that has found many supporters is the many worlds interpretation of quantum mechanics, invented by Hugh Everett in 1957. The many worlds interpretation claims that all possible outcomes of every event occur in a separate universe. No longer are we able to influence the outcome of an event simply by observing it, as is stated by the Heisenberg uncertainty principle. In each universe, their history proceeds from that point forward independently from all other universes. This conflicts with the most accepted view in physics called the Copenhagen interpretation. According to Caltech research professor Sean Carroll, the Copenhagen interpretation of quantum mechanics is actually incorrect, and parallel universes are our reality.
We don't know whether the number of worlds is finite or infinite. The straightforward and simple answer is that there are infinitely many worlds. This is what Everett himself would have believed. But we don't know that for sure, so maybe there's only a finite number of worlds. But even if it's a finite number, it's a really, really big number. So rather than thinking of the branching of the wave function as happening at special events where you work hard to make it happen, it's happening all the time. There are radioactive decays in your body roughly 5,000 times a second, and every one of those duplicates the universe, okay? So rather than thinking of like, bang, a special event splits the universe, there's a constant whooshing as the universe is subdivided. And that's the way to think about it. It's not a duplication of the world with twice as much energy and everything. There's a certain amount of worldness in the equations, and it's being subdivided and differentiated as time goes on. Think of the world as splitting, not as being copied in some way. The problem is that, there's enough stuff going on in one universe. Doesn't it seem like ontologically extravagant to add all this extra stuff in? The response to this is that once you believe quantum mechanics, the potential for all these worlds was always there. Once you believe that electrons can be in superpositions, you should believe that people can be in superpositions and worlds can be in superpositions.
Some physicists say the multiverse is not a legitimate topic of scientific inquiry, and concerns have been raised about whether attempts to exempt it from experimental verification could erode public confidence in science and ultimately damage the study of fundamental physics. Some have argued that the multiverse is a philosophical notion rather than a scientific hypothesis. Proponents of the multiverse idea often try to respond to these criticisms by saying that the multiverse, crazy as it sounds, is not a hypothesis, but rather a natural consequence of an accepted model of physics. In other words, it just follows from the laws of physics that we live in an infinite number of universes, and we will never be able to prove otherwise. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this.